Here at Station 5, we've got some electric motors, some that are taken apart, and this one, which has been connected to a battery pack, and a connects piece put onto it so that we can see how it works. So when I turn on the electricity here to this battery pack, it starts flowing. And it turns on the electric motor. An electric motor turns electricity into mechanical energy, energy that can do work. So it takes the chemical potential energy of our battery, just like we saw in the previous unit, how it can induce a magnetic field, and uses that property along with permanent magnets to create mechanical or motion energy that can do work. Now, if we take one of these apart, we see a few basic pieces. On the inside are two permanent magnets and this series of coiled copper wire. It's this relationship between the coiled copper wire that creates an electromagnet and the permanent magnetic field that causes the motion. In these electric motors that are taken apart, you can see the relationship between the coil of wire and the permanent magnets. Now, all motors have a very basic construction. There's some way to get electricity into that coil of wire, and as it spins, the electricity goes into a different set of coils. So only one set of coiled wire is magnetized at a time. And this causes the motor to want to reorient itself inside the magnetic field of the permanent magnets. So it moves, and then the other coil gets electrified and keeps it moving. So as it rotates, it switches which coil is magnetized, and that causes it to start spinning inside that magnetic field. All motors operate on this principle. They have a permanent magnet with a series of coiled wires on the inside that, as they're electrified in different ways, will start to spin. If we look at a very basic diagram of this, we see that there's a permanent magnet with a coil of wire and a way for that coil of wire to alternate the magnetic field within the coil. So as it spins, it reconnects in the opposite direction, and that keeps it spinning. So it's the changing direction of current inside that coil of wire which changes the orientation of the magnetic field, just like we saw in Station 2, that causes the motor to keep running. So, in our lab, an alternating electric current within a coil of wire will cause an alternating magnetic field. When this coil of wire is placed inside a fixed magnetic field, it will cause the wire to reorient itself and spin and create mechanical energy.